you boys and girls in the classroom should be very interested in science about energy because energy is everywhere. And I'm going to show you a little bit of energy right now.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by Invigoratease, energy for champions.
When we do something, like open a door, we're using energy. Electrical energy makes this door go up. Well, I can open the door another way with another form of energy, the energy of my muscles. See, energy comes in all different forms. Like sound is energy. Heat is energy. Falling things have energy. When we move our muscles, that takes energy. Electricity is energy. And energy can be converted from one form to another. Energy is what makes things go, run, or happen. So let's make something happen. Say with this big box of water. See, when we filled this box, we lifted the water up here. And when we did, we gave it some energy. Think about it. You have to work to lift a bucket of water. So when you lift it, the energy of lifting is stored up here. I'll prove it to you. When we open this valve, water flows downhill and runs this little propeller. The propeller spins and runs a little generator which makes a small amount of electricity. It runs through this wire and makes this needle move. Some of our electricity is made by falling water at huge dams that have huge propellers. When energy is stored, we call it potential energy. It has the potential to do something. When it's moving, we call it kinetic energy. Kinetic means moving. Now this setup converts the potential energy that we put into the water by lifting it to a form of kinetic energy, the energy of the flow. And the flowing water makes electrical energy. Kinetic energy was converted to electrical energy. Energy was changed from one form to another. Not bad. You know, I'm kind of out of energy.
Now, what would happen if suddenly there were no energy in the world? Well, first of all, there would be no electricity, so the wouldn't they? And then the wind wouldn't blow anymore, so the clouds would stop moving and the flag would stop blowing. There would be no more movement. The cars wouldn't move. As a matter of fact, all the lights would go out. Cold, dark, dead world. But lucky for us, we don't have to worry about that because energy is everywhere. Energy is everywhere.
Hey friends, are you like a lump on the plastic-covered couch? All potential energy? Do you dream of someday taking charge and fulfilling the kinetic energy?
Here, check this out. It's an energy demonstration. As I wind up this propeller, the rubber band stores energy, and that energy can be released to make the airplane fly.
Here I have some vinegar and some baking soda, and I'm going to mix them together and see what happens.
Make a rocket and you can see how energy makes things go. Just add a half a cup of vinegar to a half a cup of water. Then put a teaspoon of baking soda onto a coffee filter. Then roll the coffee filter up and twist the ends really tight. Now put the coffee filter in the bottom of the bottle. Put the cork on as tightly as you can and hit the dirt.
Okay, put the top on, shake it up, it popped right off, it popped right off, it popped right off.
The baking soda and vinegar cause a chemical reaction that builds up pressure inside the bottle. The cork pops off because the chemical energy changed to moving energy.
Energy makes things move. It made that cork move off before we had a chance to show it to you.
It makes things go.
It makes things move.
It changes form. It's energy, 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 energy.
So I think that we might at this time say that energy makes things move.
Energy makes things go.
Makes things move. Energy makes things move.
Howdy, folks. I'm Ken Eddick, your host, and I'm here with the ever-energetic Violet Light. You all know the rules. We spin the wheel of energy, and we change one type of energy into another type. Okay, Violet, convert some chemical energy into kinetic energy and give the wheel a spin! That's what I call sound energy.
I think you can see why we call him Mr. Sound Energy. He's like that all day long, aren't you, Jerry?
We're just going to go. We're not going to rehearse. Good. Love it. Okay, here we go. Here we go. Right now, this bowling ball has energy. It's not moving, but it's got energy. Please consider the following. You ready? 3, 2, 1. It looked like it was going to smack me right in the head, didn't it? I mean, it's a bowling ball. It would knock me pretty good. But it'll never hit you in the head. Because when we pulled the bowling ball back from the middle, we gave it potential energy. When we let go of it, it had kinetic energy. The kinetic energy will never be bigger than the potential energy. It's only going to have as much energy as we gave it when we pull it up here from the center. It works every time, unless you give it a push or something. Oh, sorry.
Energy can be changed from one form to another.
Electricity is a form of energy. You're using some right now. But do you know where electricity comes from? Do you? Oh, come on! A lot of it comes from the heat released by burning coal. The coal makes heat. The heat makes steam. And the steam is running this small turbine. The turbine is actually an electrical generator. And we can read the electricity on this gauge. This is the same way it works in a real coal plant. Except there's more coal, more steam, bigger generators, and more electricity. We can use the energy of falling water to make electricity. The falling water spins a giant turbine. It's like a big paddle wheel. And that runs an electric generator that makes electricity so you can watch the show. Nuclear power comes from atoms. Inside the atom is the nucleus, the middle. Now, some atoms have nuclei that are so big and heavy they're always falling apart. When we bring these atoms near each other, they get hot. So hot that we can make steam, and then electrical power. There's energy in the wind, too. Wind turns these propellers. They're windmills. The spinning blades turn electrical generators. We're converting the energy of moving air, wind, directly into electricity. The sun is beaming energy to the earth all day and all night. Solar panels made of the same material as microchips change sunlight directly into electricity. Well, now you know where electricity comes from. You realize that you gotta conserve it. Only use it when you need it.
First came the dam. A
A series of great barriers that eventually will
A
transform...
waterfall higher than Niagara, Grand Coulee Dam. Spillways begin to flow. Power to turn the wheels of America.
This is Grand Coulee Dam.
Grand Coulee Dam.
I'm Jane Rollins. I'm a dam operator. The water is behind the dam, about 100 meters above us. And that water rushes down through these water pipes called penstocks down to drive the turbines. We're inside the penstock. Normally this is filled with water. This spiral case looks like a giant snail shell, and it goes around the turbine. This is the turbine. It's a giant propeller. The rushing water up above creates thousands of tons of energy to make this turbine spin. The spinning turbine turns these generators, which produces electrical energy.
And electrical energy may be turned into light energy, or heat energy, or even back into motion energy.
This is a laser. It converts electrical energy into heat energy by making gas molecules vibrate at the same speed as heat waves. Now this laser has only about 500 watts. That's only as much as 5 average everyday reading lights. But the energy is so concentrated, it's in such a tiny space that it's able to burn right through this plywood. It's energy being converted from one form to another and then making something happen. Isn't that cool? I mean, hot?
Who knows what potential energy lurks in the heart of things? A transformer.
Take a look at this energy experiment of science. Take a look. These are big, heavy rubber bungee cords. And this is a sandbag. It's a heavy weight. So the weight holds the center of the bungee cord still. When the barrel rolls, they twist, storing energy in the rubber. Watch. When I give it a kick, it's storing energy. See, the weight holds the middle of the bungee cords tight, so they wind up. The energy from the kick is stored in the bungee cord. As it rolls back, we get that energy back as kinetic energy, see? Oh,
The motor which moves this toy changes the energy stored in the toy's batteries into motion energy.
This pool is just energy that's stuck behind the waterfall, and then it goes down into here. This is the valve that lets the water go down into the pipes. These are the pipes that the water rushes down to the powerhouse. And it hits the turbines. This turbine changes the energy from plain old water into electricity. My dad built this power station on this stream. So we take the energy from the water and produce it into electricity.
One of the big sources of energy that we use is oil. Well, oil is a fossil fuel. Fossil means something that we've dug up. We don't really dig it up, we pump it up. Now, oil is pumped out of the ground. Now, this shaft goes down about 500 meters. Every time this rod goes up and down, it brings up a little bit of oil. It goes out a pipe here to a big tank, and eventually it might wind up in your car. Now, that much steel is heavy, so we have these big counterweights that keep the thing in balance. It's called a grasshopper pump because it kind of looks like grasshopper. Kind of. Anyway, oil is a chemical that we combine with oxygen in the air to make heat. It's a source of energy.
The energy stored in this wood is changed into heat and light energy when the logs are burned. We store energy in ourselves by eating food.
Energy changes form in your body all the time as food is being broken down into fuel. Some of that energy turns into heat. Watch. Smear a coin with some cold water. Then, smear the top of a glass bottle that's already been refrigerated. Now put the coin on top of the bottle. Put your hands around it for about 30 seconds. Whoa! Did you see that? See, even when we're just chilling out, our bodies are changing energy.
But where does this energy come from?
My body produced enough heat to warm the air inside the bottle and cause the coin to jump, jump, jump.
We get energy from the foods we eat.
Energy is cool.
The energy we get from food began as light energy from the sun.
Right now I'm using a lot of energy. Chemical energy I get from my food. Only about 40% of it is used to move around. 60% of it's turned to heat. That's why you get so hot when you exercise.
Energy is everywhere.
Energy. 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 Energy.
Energy. Energy, because some of you are going to be using energy.
Energy is needed to help things move and grow and grow.
New from Quantum Toys.
Turning one kind of energy into another. Energy Transformer. They're your energy pals. Better get some today.
Energy is what makes things go, run, or happen. Like energy is what makes this bike roll. Now, energy can be converted from one form to another. And that's what happens when we convert chemical energy in the food we eat into the energy of movement to make the bike roll. Now, whenever energy is converted from one form to another, a little bit of it ends up as heat.
Let's take a look at heat energy and see what heat has to show us.
These big black bungee cords are storing energy. When we let go, it'll become kinetic energy. Oh! 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 Well, that's our show! Yeah, I hope it was kinetic enough for ya! Hope it lived up to its potential! See ya!
Produced in association with the National Science Foundation.
Microwaves make water get hot.
Hey, maybe I could put this on. Daryl, listen, I put this on, this is all, and I go like this.
Microwaves are energy. And as the microwaves go through water molecules, they make the water molecules rub on each other, like this. And that's how microwaves pop popcorn. The water molecules turn to steam, and they explode, making the popcorn kernels turn inside out. Now, the molecules don't explode, just the kernels. Molecules boiling, turning to heat. It's popping, it's popping, it's popping! The water is turning into steam. The steam's expanding, blowing the kernels.